Polygonal complexes in South America represent a systematic assemblage of formatted rock outcrops and polygonal structures integrated into the terrain. In the third part of the series, Traces of Alien Technologies, a hypothesis was presented suggesting that, in essence, they are configuration-based complexes. The main conclusion was that configurations, whether based on modified natural formations or on artificial structures, are not landing sites or platforms for some kind of equipment. They are the equipment itself. One of their functions was to define a specific spatial area and maintain it in an active state. This conclusion applies to all types of configurations, at all levels, both isolated and standalone ones, created on small rock outcrops or on separate boulders, and large-scale complexes consisting of multiple polygonal objects. Based on the purpose and method of implementation, three relatively independent types of configuration complexes can be distinguished. Polygonal complexes are just one of them. They simply appear more striking due to the compact arrangement of multiple objects with characteristic technological features. Their main part consists of structures built using polygonal masonry. Configured excavations are present as isolated elements and mostly as secondary components. The second type includes complexes where configured excavations are predominant, either without the use of polygonal masonry structures or with their occasional inclusion. These are configuration-based complexes created directly on rock outcrops. Examples include Nalpa Iglesia, the Temple of the Moon, and the Temple of the Monkey. The third type consists of complexes in which structures made of polygonal masonry and configured excavations are present in relatively equal proportions. This is not merely a combination of the first two types. Such a complex consists of elements created on a natural base, while the polygonal structures within it are substantial and independent. However, they are not autonomous. They complement each other. An example of this type can be seen in Cuenco. The reasoning behind the use of this particular type of masonry, polygonal with curvilinear joints, was explained in the second part of the series, Traces of Alien Technologies, in the episode dedicated to regular structural rules. In a condensed form, these arguments can be summarized as follows. Natural resources are limited. Even in a mountainous region, it is often impossible to create a structure of the required size and configuration from a solid rock outcrop. Polygonal masonry, however, allows for the construction of complex, large-scale structures, and in any location, even where there are no rock outcrops at all. There is also another significant reason. Different types of stone have varying degrees of strength. They also differ in porosity and density, factors that determine their ability to absorb moisture, which is especially important in mountainous areas exposed to winds and significant temperature fluctuations. Additionally, rock outcrops are naturally prone to fracturing. If a large configuration were built entirely from a single rock mass, its behavior would be unpredictable. Therefore, it is more practical to create a structure from separate elements with the necessary properties whose behavior can be accurately calculated. Polygonal blocks and polygonal masonry with curvilinear joints fully meet these requirements. They combine all the necessary qualities: strength and reliability, the ability to form the required shapes, and long-term durability. Complexes predominantly based on configured excavations were mainly analyzed in the third part of Traces of Alien Technologies. Now we will take a closer look at polygonal complexes. Several distinct types of structures can be identified in the above-ground part of polygonal complexes. The first in this series are the structures that form the foundational configuration. These are terrace-type platforms with facings made of polygonal blocks. The shape and size of the rock outcrop used as the base for the complex were often modified. This was achieved by adding embankments of soil and stones of various fractions. The resulting structures were then faced with polygonal masonry. The next group consists of individual structures built on this prepared foundation. They were constructed using megaliths or with double-row polygonal masonry. A combination of these methods is also common. In many structures, megaliths and polygonal masonry made of smaller blocks complement each other. There are several structural features that indicate the technological purpose of these structures, showing that they were not intended for habitation. These include a trapezoidal profile and inward-leaning walls. There is also a lack of roofs and structural elements that would suggest the presence of coverings. Additionally, all walls are load-bearing. There are no partition walls inside the structures, nor shared walls or passageways between closely spaced buildings. The shape of such structures can vary from rectangular to oval. Their sizes also differ. For the most part, they are small, single-story buildings. However, in rare cases, more as exceptions to the rule, there are structures of considerable size and even ones that may have had multiple levels. Another essential category of objects is standalone configurations. These can be created from small sections of rock outcrops, such as the Intihuatanas, or they can take the form of large configurations, like the structures in Pisac. Some are carved into isolated stones, like the chair in Ollantaytambo. Others are built using megaliths and polygonal masonry, such as the U-shaped configurations in Machu Picchu. A separate category includes small, protruding rock outcrops encased in polygonal blocks. In some cases, the masonry completely covers the stone core and fits tightly against it, creating the impression of a monolithic structure. In other cases, the masonry stands slightly apart from the rock core, with the space between them filled with soil and stones. This makes the structure appear more voluminous, emphasizing each of its components. Another typical feature of the above-ground part of polygonal complexes is the presence of hydraulic system elements, such as aqueducts and waterfalls. Such structures could create and maintain specific configurations of water flows, as discussed in the episode on hydraulic engineering structures. Their function within the framework of configuration complexes is more complex and technologically advanced than the purely utilitarian task of water distribution and supply. Together with stone-based configurations, water flow configurations contribute to creating an environment with specific properties and sustaining it in an active state. In polygonal complexes, in addition to above-ground structures, it is also essential to consider those located underground. The foundation of any complex consists of drainage systems. These structures can be divided into two major groups. The first includes those located in the near-surface zone: ditches, drains, runoff channels, and artificial terrain features designed for water absorption and drainage. The second group consists of artificial drainage structures, as well as sections of aqueducts located beneath the surface. This category also includes underground voids found within the complex areas. These include rock fissures, grottos, and caves. They could be used in their natural state without modifications or added details. For example, in Machu Picchu, such voids were known to serve drainage purposes. However, they could also be altered and adapted for more complex functions. The underground karst system, La Gran Chincana, stretches from the Temple of the Sun in Coricancha to Chincana Grande in Sacsayhuaman, covering a distance of about 1.5 kilometers. In August 2000, during the Viracocha project in Cusco, studies revealed the presence of an entire network of underground structures, crypts, and cavities beneath the city, some of which were artificially created. This confirmed the testimony of Garcilaso de la Vega, who once recorded in his chronicles. The network of underground corridors is vast and intricate. The system consisted of a complex of streets and alleys diverging in all directions, with identical doors everywhere. Understanding this layout was so difficult that even the bravest enthusiasts did not dare enter the labyrinth without a guiding rope. Artificially created configurations of various types, niches, seats, and stepped structures, are frequently found in underground chambers. The ceilings are sometimes designed as diagonal slopes. In some grottos, complex structures made of polygonal blocks were also built. A good and, most importantly, accessible example of artificially modified underground spaces can be found in Cuenco, in Machu Picchu. The entrance to the underground part of a configuration complex was sometimes modified artificially, as seen in Nalpa Iglesia. The above-ground part of this complex consists of a series of separate structures. Among them is a basalt rock formation featuring a set of configured excavations. To the right of the entrance to the underground part, there is a composition of configurations with perfectly proportioned elements, a niche embedded in a long horizontal seat. One of the rock fragments features a configured overhanging lower section. The entrance to the cave itself is particularly noteworthy. It is formed by several large rock fragments. At the same time, they appear to be deliberately arranged in this way. Unfortunately, the basalt rock shows signs of damage. It is now impossible to determine what the original configuration composition once looked like. On the left side, drilled holes, test pits for explosive charges, can still be seen. One of them was never used, so it remains intact. However, another hole nearby, along with a remnant of a hole in the central part, is only partially preserved. The surface characteristics of the upper and left parts of the object indicate that an explosion occurred there. According to official accounts, the rock once served as an altar. It was supposedly blown up by treasure hunters back in the Spanish colonial period. To this day, legends persist that the Incas hid their gold somewhere in this area. It is also possible that this was part of a campaign to destroy sites revered by indigenous people. After the Inca uprising led by Manco Yupanqui, the Spanish deliberately destroyed many of their sacred places. Configurations in the form of a long horizontal seat at the entrance to underground complexes are not unique to Nalpa Iglesia. In Cuenco, for example, a similar object is found, but in an inverted form. A complex with a similar set of configurations, both underground and above ground, can also be found in the temples of the Moon and the Monkey near Cuenco. There are many common features among different polygonal complexes. The variety and number of objects within them are not particularly large. However, it is impossible to find two completely identical complexes. The terrain of the foundation, the layout, the set of objects, the appearance of structures, directly linked to the type of polygonal masonry used, and many other factors make each one a unique site. It seems that not only the complexes themselves, but also individual elements within them were created for a specific location, or for a specific purpose. They were built using typical components that suited that location and its functional requirements. This makes it even more surprising when objects in different polygonal complexes, located far apart, feature sections of masonry that strongly resemble each other. For example, the large trapezoidal opening in the Asterisk Temple of the Ten Niches in Ollantaytambo, the gateway in Pisac, and the entrance opening in Sacsayhuaman all appear almost identical. From photographs, an untrained observer would struggle to determine which of them belongs to which complex. One possible explanation for this similarity is the use of the same polygonal technology. However, this explanation seems insufficient. Other nearby sections of these same structures are already different from one another. That said, such similar sections are not very common, and even when they do appear, their resemblance is not absolute. By examining additional details, such as the texture of the block surfaces or their color, it is still possible to determine which complex a given masonry section belongs to. Even within a single complex, the appearance of structures can vary. Side by side, one may find objects built from different types of polygonal blocks, or objects with varying degrees of refinement on their facing surfaces. As a result, the facades of buildings can differ significantly. Some structures also feature sections of masonry made from different types of polygonal blocks. In the battlements of Sacsayhuaman, for example, sections containing all types of blocks can be found in various combinations. It is also known that, for various reasons, some structures were occasionally dismantled. There could have been multiple reasons for this. Among them, the simplest. The structure no longer met requirements and needed modification or even complete demolition. There are numerous examples of blocks that had previously been part of masonry being reused, either in their original form or after some reworking. In Ollantaytambo, there are especially many structures built using repurposed blocks. These include long rectangular blocks of pink porphyry, as well as polygonal blocks that still retain the detailing of their former facing and side surfaces. However, blocks from dismantled structures were not always reused. In Ollantaytambo, many second-hand blocks, both grouped together and scattered individually, are spread across the complex's territory. In Sacsayhuaman, within the rubble fillings, so-called bricklet blocks have been found buried. For some reason they were not used, even though they are intact and appear perfectly suitable for construction. It is obvious that polygonal complexes did not emerge in the form that we now observe. Judging by various signs, in some, especially large complexes, the process of forming the structure of the object and its refinement was never fully completed. Sections of polygonal masonry that can clearly be described as unfinished can be found in Sacsayhuaman. They can also be observed in Cusco and in Quilarumiyoc, and there are many of them in Ollantaytambo. Machu Picchu also shows signs of gradual formation, but these are somewhat different in nature. There are no sections that are clearly unfinished, but there are indications that the structures appeared in several stages, separate groups, not all at once. The structures in these groups share many common features. The technological characteristics of the constructions, the principles of their building, and the materials used are all identical. And, it seems, They all served a common purpose. However, each group has its own preferences regarding the type of blocks used, in terms of their size, in terms of the appearance of the blocks facing sides. This suggests that Machu Picchu underwent several distinct and successive stages of construction. It is clear that the major features of most polygonal complexes were indeed formed. It is also clear that the process of their formation was somewhat stretched over time. Initially, they consisted of small objects made of basic elements. These elements dictated both the direction and structure of further development. In their zone of influence, it became possible and necessary to build other related objects. And the area of the world affected by them was organized according to these principles. It is difficult to answer the question of what exactly might have served as the foundational basis for such environmental structuring. In each case, even when purely natural origins are considered, the base might have been different. These could have been underground cavities, exposures of rock, water flows. There might have even been a special ratio of climatic and geophysical characteristics at the location. It is clear that not every natural formation can act as a catalyst for environmental structuring. The object must have the potential for expansion, and the process of expansion must be activated properly. If we take such an initial object as the basis and trace a vector from it to the finished polygonal complex, we can create a quite coherent evolutionary sequence. In this sequence, it is easy to distinguish certain stages that, due to their distinctiveness, can be considered separate steps. In the case of a rock outcrop, using it as a foundation sounds literally like cornerstone. This resonates with many ancient legends and myths. The natural origin, size, and location of this object should allow for the creation of a basic configuration on its basis. Following the principle of moving from a basic variant to more complex variations, the stepped type configuration is the most fitting for the primary structure. It allows for the simplest format of the delineated space, 1-to-1, one horizontal and one vertical plane, or 1-to-2, one horizontal and two vertical planes. Another variant of the primary configuration might be chairs. Their delineated space format is 1-to-3, one horizontal plane and three vertical ones. If constructed on a separate boulder, such configurations could represent a mobile version of the cornerstone. We cannot exclude the simplest plastic type of configurations. Near the channel at Combamayo, there are several outcrops of rock with flat, clearly artificially smoothed tops. The next step could be the creation of more complex excavated configurations based on the chosen natural foundation. And then, a compact group of excavated configurations could be formed. Through this process, a whole area of space is delineated. Then, when there is a need for larger-scale configurations, the issue is addressed by objects created using polygonal masonry. Next follows the stage of forming a complex of configurations with a number of polygonal structures, which is accompanied by necessary terraforming. The sequence of events might have started differently if the foundational element were, for example, not a rock outcrop, but a water flow. In that case, the basic artificial element would have been a configuration made of polygonal blocks directly linked to the water supply, setting a certain format for the flow. It is possible that small rock outcrops could also have served as the foundation after their configuration was worked on using polygonal block cladding. Or underground cavities, perhaps their presence, followed by transformation through configurations, could have served as the basis for the development of a full-fledged complex on the surface. This sequence of events seems quite logical. Each complex is essentially a variant of the unfolding potential contained within a natural origin base object. The collective of these base objects serves as the foundation for a particular topology. Another question related to base objects cannot be overlooked. It concerns cases where there is no object in a location capable of becoming the core foundation. This suggests the possibility of creating such an object artificially. For water flows, the solution could involve bringing a water conduit to the necessary place, even if it is several kilometers away. But, for example, in the case of a rock outcrop or underground cavities, this becomes more challenging. It is not easy to create them artificially. For such an object to appear in the necessary place, conditions must be provoked that would make their appearance possible. In Sacsayhuaman, there is an example that could be interpreted as the artificial creation of such a foundational object. This is the Rodadero rock, an outcrop of diorite formed when material in a viscous state was squeezed through limestone onto the surface. It is known that similar phenomena occurred around Pisac, Cusco, and Machu Picchu. This is not surprising. The Andes is a seismically active zone. Similar occurrences can be observed in many other parts of the world. At the Sacsayhuaman outcrop, the hill, with a wavy form and polished surface, is quite spectacular. It surprises people and gives rise to the most incredible speculations and fantasies. Nevertheless, it is worth agreeing that the idea of artificially creating the conditions for such rock outcrops is somewhat excessive. Nature provides enough natural rock outcrops, especially in mountainous areas, to warrant going to the trouble of creating them. When a foundation needs to be established in a specific location where natural rock outcrops are absent or insufficient, there is a simpler and more reliable way: polygonal masonry. And its purpose has been mentioned several times already. An area of particular interest is the final stage of the creation of polygonal complexes. Once sufficiently formed, they become part of a system of configuration complexes. This system involves all three types: polygonal complexes, complexes of configurations based on natural foundations, and their combined variants. In essence, they form a homogeneous environment consisting of several individual elements with common technological features and properties. Each element complex plays its own role in this system. This could be compared to the environment formed by ordinary residential settlements, industrial, and cult structures located within a certain territory. We also configure space actively in many spheres. But in this case, the analogies are relative and quite superficial. The environment we create serves one sole purpose: to ensure the comfortable existence of humans. Everything in it is subordinated to this purpose, and everything evolves and changes according to this principle. In contrast, the environment formed by configuration complexes has different priorities. People can inhabit them, but only under one rather rigid condition: the buildings, configurations must be refined, with consideration for needs, even for human physiology. This condition was always met when it came to human use of these complexes. It was followed in the past. Before using polygonal structures, the indigenous peoples altered their designs. For instance, to ensure at least relative comfort, such as providing a roof over their heads, they attached gable walls made of roughly hewn stone above the polygonal walls. Similarly, the same thing is done now. It cannot be said that this benefits the complexes. Their exterior and the details of their construction are recreated according to current interpretations of their purpose. They're transformed into entertainment centers, stages for costume and light shows. They become places of worship. We also end up with structures that are externally similar to individual configurations. Talkie for products of technological processes, for example, from ore or stone extraction. Again, any analogy would be superficial here. Without knowing the purpose of the structure and relying only on its external features, it is easy to make erroneous conclusions. For example, from just the outward appearance, one might conclude that the main purpose of a hydroelectric dam is to create a spectacular artificial waterfall, or to form a vast reservoir. Similarly, the functions of hydraulic structures in South America are not limited to purely domestic needs. Paleohydrologist Kenneth Wright, after studying Tipon, stated, "The source that feeds the main system of channels at Tipon includes a complex system of riverbeds, which primarily multiply the water paths to later regroup them in a play, the ritual significance of which, unfortunately, eludes us." It seems the Incas also understood this. They knew it and tried to adhere to it. Liquid circulation held one of the most important places in their religious system. Polygonal complexes are complex objects to study. Most of the changes they made to the environment remain undetermined. We cannot pinpoint exactly how or by what means they adjusted it. Those who created them clearly had something in mind that does not align with our requests and requirements. Therefore, we are unable to use them for their original purpose. For us, they are non-functional. As a result, imposed meanings and interpretations of their purpose, in most cases, turn out to be foreign to them and do not take root. And forced adaptation to modern humans leads to absurdities. In essence, this is akin to decorating an aborigine with bottle caps and other scrap metal. The same applies to the technical side of the matter. The nuances of polygonal technology cannot be fully explained by even the most sophisticated versions, which practically ignore physics, such as plasticity, blowing, or disintegration. The version that accounts for all observable tool marks on the blocks suggests that the work had to be done with hard materials. However, this, in turn, requires tools with very specific and specialized qualities. Most versions regarding tools and their capabilities remain debatable. The stone was processed so masterfully and on such a scale that the principle of the tool itself must differ from what we use. It is also evident that its topology should align with the topology of the location that conditions and generates it. Some indications suggest that this might be an area that, to some extent, lies beyond our perception. The same questions apply to the phenomenon of Nazca and Palpa. A three-dimensional reconstruction of the intersections and overlaps of figures and lines on the plateau shows that their appearance and many of their details are closely related to changes in the terrain. The source of the phenomenon should have been located at some height above the surface. Electromagnetic studies indicate significant changes in the soil's state under these objects, up to 2 meters deep. And this alone suggests that the version of their creation using primitive tools, by simply moving stones from one place to another, is completely unsuitable. Finally, there is one more intriguing point that I would like to mention to conclude this cycle. It concerns the polygonal complexes and configuration complexes. They are effectively deactivated through widespread destruction and transformation. Nevertheless, it is not excluded that some parts, some individual elements within them, may still be in working condition, or perhaps retain residual traces associated with their original functions.